Section 8.6, Law of Cosines. What we're going to do is learn how to use it and when to apply it. So on this one, I let you do the law of sines and your postulates and theorems yesterday, so I'm going to let you do cosines as well. However, I do not want you to do all three of those formulas. I want you to do the last one only. Okay, so only the last one. It's going to be too confusing doing three, and the letters never match. So I want to let you know how you can apply any letters to one formula instead of having three and wondering which one you use when the letters don't match. Okay, so law of cosines, make sure you write that down. And then do the third formula only. This is another way that when we are solving triangles that are not right triangles, that we can actually find those missing parts. So when law of sines doesn't work, what do? We can use law of cosines, okay? Sometimes when you set law of sines up, it doesn't work. There's no way that it can work because no matter what you do, you always have two variables missing, okay? So law of cosines is one of those things that's going to help in those cases. Law of sines is definitely easier to use, but once you do cosines a few times, it doesn't, it's not extremely difficult, and it does look similar to things that we've already done. So law of cosines is c squared equals a squared plus b squared minus 2ab cosine c, and remember the opposites do matter on this one, and that's why I did opposites on sines as well. So if you have a capital A, that's an angle. If you have a small a, that's the side opposite that angle. So when you look at this formula, what does this first part look like? C squared equals a squared plus b squared? Pythagorean theorem, and that's why I picked this particular one, is because we have something that we can go off of that we already know. The next thing in the formula is minus 2ab. Notice these two letters are a and b, so whatever two letters you have on that right side, that's the two letters that go in here. Notice on the one above it, a and c, so you have a and c in there. So once you actually get that first Pythagorean theorem part written, the two letters that are on the right are the two letters that you multiply by 2 and also multiply by the cosine of c. Notice how this is the side c, that's the angle c. So if you are missing one of those two, those are the two that go on the ends. Okay, and I'll explain this again when we're actually using numbers. This can be used on side angle side and side side side, but I don't want you to write that down. You can write it in your notes, but not on your postulates and theorems page. I usually don't look at it like that because I feel like if you're going to use this later, you then know that. But for now, check sines first. If sines doesn't work, go to cosines. That's the easiest way to do it. Then you don't have to remember anything extra, and you can kind of just go from problem to problem. So solve for b to the nearest tenth. So when we're looking, don't write this part down. I'm just going to show you my thought process here. So I notice that I have this right here is kind of like an angle side pair. This one right here, 10 and c, I don't know one of those. And a and 22, I also don't know one of those. To use law of sines, you need at least three things, right? And only one missing. So if I did law of sines here, it would look like this. Sine 44 over b, which looks fine, equals sine a over 22. Can I do that? No. If I changed it to go to the other one, I would have sine c over 10. Can I do that? No. So it took me like less than 20 seconds to write both of those and go, okay, law of sines doesn't work on this one. So we're going to backtrack a little bit. And we're going to plug these into the formula, which means if law of sines doesn't work, law of cosines will. Okay, so I circle my angle side pair that I want to find first. What I do is I look for either an angle that's given and the side opposite isn't, or the other way around. You need a pair. So I'm circling that one for a reason. My b is going to be on the left. Okay, so it's going to be b squared equals the other two, a squared plus c squared. minus 2AC cosine B. Okay, so I wrote out my formula. Whichever one you're looking for goes here. Whatever angle that matches it goes there. Sorry, tapped that. The other two letters are the two that kind of fill in the middle part. So this one doesn't exactly follow c squared equals a squared plus b squared, but that's the one that you'll remember eventually as your formula. Now let's plug stuff in. We don't know the b, so I'm going to leave that like it is. The a is going to be the 22, right? So 22 squared. The c then is 10 squared minus 2 times 22 times 10 cosine b, which is 44. Now, do you really have to have the 22 in for the A and the 10 in for the C? Is that really going to matter when you're calculating? No. So I normally do not put them in exactly like the formula says. I find my angle side pair like this. The other two can go in any order that you want. It doesn't matter because you don't use the angles and sides together after that anyway. So the next one I'll do that way, and not like plug them in and write a formula so that you don't have to be so nitpicky about a formula. The only two that really matter right now is side B, angle B. That's the only two that kind of make this problem work. So now that everything is on the right, let's type it in. So grab your calculator, type all of that in at the same time. Notice in between the 2 times 22 times 10 times cosine 44, all of that is a product. Okay, so you're going to just type it all in. And you have to be in degrees. And then don't clear your screen. I'm just going to write what I'm looking at right now. And I might have typed that in wrong. Hold on. Just have it right. You just need it around here. Oh, I think I wrote it wrong on my paper. That's why it looks weird. Yeah. Okay, so now what do we do to find just B? Square root, call up the answer. Don't type it in again. Even though I wrote it like this on my paper, you guys could go right from here to the answer because it's all on your calculator, okay? So if you wanted to skip this b squared equals that number, that's okay. If we square root both sides, I'm just going to show that so you don't forget what to do. So b is approximately 16.4. So here's what I need. I need a formula of some sort and then the answer for this one. So kind of a long formula, but like I said, once you do it a few times, you'll know where the numbers are coming from, and you won't really need to know that one formula that we wrote down. Okay, so let's solve another one. This one says solve for L, which is going to be this one. Okay, so first thing you want to do is locate your angle side pair. This time the only angle we're given is 104. So I'm going to circle that. What does that mean? That means the L is going to go on the left side of my equation. The 104 is going to go in that cosine part. The other two can go wherever you want them to go. Okay, so here's what it looks like. L squared equals 48 squared. Notice I'm not being concerned with which order these are in because we're adding them. It doesn't matter. The two that I just wrote down are the two that you multiply by 2. And then it's cosine of the angle that goes with L, which is 104. Okay, that's how I do it every time. I don't look at the formula. I don't pay attention to where they go. The only ones I'm really concerned with are these two. First one, last one. The side goes here, the angle goes there. Now, we're going to do some in a minute where the angle's missing. That's a totally different story when solving them, but writing it goes the same every time. So again, I'm going to write the L squared number. You can skip over that if you can go right to the answer. I get 3818.51. And then you square root both sides. So square root and call up the answer, and you get about 61.8. Those are the two things that I need. So when you're looking for a side, law of cosines is very easy to use. It's a longer formula, but I think once you do it a few times, you'll know where those numbers go. What do you do when you're solving for an angle? Okay, we're looking for angle V, so that's going to be my angle side pair. Since we're practicing cosines, law of sines wouldn't work because we'd have two missing angles. Can't do that. Okay, now at the beginning it said it works for side angle side and side side side. Well, this is a side 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 one. If you look at what we had before, we had a side angle side. Okay, 48 was a side, 104 was an angle, 29 was a side. It works for that also. So if you want to look for that, you can. So we're solving for V. So this time we have 4.4 squared, because that's the side, equals the other two squared. Again, the order for these does not matter. Minus 2 times the ones we just wrote, cosine V. So this one's different. The thing you have to remember is this part right here needs to stay together because it's a product. The other two things you can get rid of, but this part right here stays like it is. So what I'm going to do first is I'm going to multiply these numbers together so I don't start like adding them to the other side. The mistake is not made when it's written, it's made when it's solved. And this should be something that's easy, but we haven't done it before. So what I'm going to do is first of all multiply those so I can get it as one number. And I'm going to leave these for now. Okay, so I'm multiplying 2 times 7.1 times 6.7. And I get 95.14 cosine V. Again, this stays together, so don't do anything with it now. But how can I get 7.1 squared to the other side? What do I do with it? Add it, subtract it, what do I do? What's ahead of it when there's no number? Plus, how would I get to the other side? Subtract it. So the other side's going to look like this, and I don't want to write down those big numbers. That's why I'm leaving them the way they are. So it's going to be 4.4 squared minus 7.1 squared. Do I also subtract the other one? Yep, I'm going to minus that one too. And it's going to equal negative 95.14 cosine V. Once you get these together, it'll look like the problems with sine where we're looking for the angle. Okay, so let's do that. 4.4 squared minus 7.1 squared minus 6.7 squared. If I am trying to isolate this cosine V, how would I get the negative 95.14 to the other side? Divide. And that's the key. The place where most people go wrong is that they want to add 95 to the other side. It's division because it's a product there. So I'm dividing by 95.14. Also the negative in there. And then I'm going to hit my equals, so I divided those two on the left side, and I'm getting 0.798 about. I'm keeping it on my screen though. how do we get V? Looking for an angle, do we use cosine or second cosine? Second. So V equals inverse cosine of whatever's on your screen. So now hold it there. So you're going to do second cosine, call up that answer, hit equals. What kind of an angle are you looking at? 37? And there's no decimal place. It doesn't round up at all. So I'm just going to say 37. That is probably one of the harder ones that you would have because really there's only two scenarios. You're either missing the side on the left or you're missing the angle on the right. Two things that you got to know for cosines where there's only one. Well, no, there's two for sines as well. If you're looking for the side, all you do is multiply. When you're looking for the angle, you have to use the second function at the end. So it's kind of similar, but again, most people make their mistake through here. They want to add it to the other side instead. If we do that, sometimes you will get an error. I'm going to do that and just see. It probably wouldn't work all the time, but you get an error this time. So if I happen to add this to the other side, I get a 19.2. If I do second cosine of 19.2, I get an error. So sometimes it might work that it's going to go, I'm doing something wrong here. And you're either typing it in wrong or whatever, but it may not work every time. Okay, so that's the problem is if you get an error, you're probably doing the steps in the wrong order. So let's try another one of those. Okay, they want angle T this time. So I'm going to have you guys do this one at the top of your assignment, please. Take a clean sheet of paper. Write out the formula. And you don't have to write out the formula first and then plug them in. Write it out kind of how I was kept telling you how, because it's much easier doing it that way, because the letters generally don't match, and that's the hard part. What?
It's not writing.
It will. It'll catch up. Mine is unpaused here. Hold on. Okay, there it goes. Thanks. Okay, so how many people got 76.4? Maybe some of you aren't done yet. Good. So at the beginning, I wrote the formula out. The 7.1 and t go together. This is the side, so the side goes on the left. The angle always goes on the right. And then I subtracted my 4.4 and my 6.7 squared, and I got negative 13.84. I also multiplied my 2 times 4.4 times 6.7 so I could put them together. If you don't do that, sometimes students want to separate those and you can't really do it unless you divide by them separately, which doesn't make sense. So multiply them first. I got negative 15.96. Then I divided that to the other side, and I got the inverse cosine of 0.235, and the angle I got was 76.4. There's not really any way that you can check these necessarily. Someone asked yesterday too, is there any way that you can check it like using the Pythagorean theorem or something? There really isn't, because these are not right triangles, so you can't use the Pythagorean theorem, and that's why we're using them. The only way that you could do a little checking is if you had to solve the triangle. If we were solving this one, 76.4 would be my biggest angle because it's opposite the biggest side. So everything else that I find has to be less than that. And then what you could do is you could compare. If I got U, is it my middle angle? If I got V, is it my littlest angle? Because I'm comparing the sides, and the angles that go opposite them kind of go down accordingly too. Other than that, you can't really check them in an easy way. You'd have to solve it and then compare the sides. And that's all I have. Does anybody have any questions on that formula or how to use it? This, again, is the harder scenario when you're looking for the angle. But if you do it a few times, I think it'll be okay. The most work is usually shown on this one. But once you know what to do, you can get by with less in the middle. I really need the formula at the beginning and the answer at the end.